Alright, this video is going to go over the Unit 3 review. Since we don't have class time to go over that, hopefully you're able to watch this and get a little bit of understanding of what you should have. This is for Algebra 1. So if you are in geometry and you mistakenly watch this video, it won't hurt anything, it just won't help you a whole lot on your tests. This is for Algebra 1. Okay, I'm going to start off by telling you that it does you no good to copy this information down. If you turn in a review that looks identical to mine, I'm not going to give you points for it. I can tell if you have either done your own work or if you just copied answers down. So make sure that you are just using this to check your answers. More importantly, it's not going to help you get ready for the test. If you copy all this down by watching the video or by looking at the PDF file that I put on Canvas, it really doesn't help you prepare for the test. So if you haven't completed the review yet, make sure you give that a try first. Make sure you watch the video after you've done as much of the review as you can. But you can use this video and the explanation to get a better idea of how to do the problems and then try and do them on your own. That's fine. But again, you should be using this for study purposes only. Alright, so we're going to go through this kind of quickly. If you need to look at an answer more, or if I'm moving too fast, remember, you can pause the video. Just pause the video so you can see what the answers should be. I'm not going to go over every single problem. The video would be too long. Okay, on these first ones, using domain and range, 1a is a function, 1b is not a function, 1c is a function. Notice that I'm using my set or interval notation on this one. Okay. Going on to the second page. All right. The important thing that you need to notice here is, and I believe I had some of you actually change this. Change this number to a 4, or maybe you talked to Mr. Hawkins in strategies and he told you to change both of them to a 3. Either way, we want the base of these exponential functions to be the same, and that way you see that this function right here is the one that will increase more quickly because the exponent is always 2 more than whatever x was. Okay? Okay, number 3, we graphed it. Notice the scale we came up with. Okay, we've got to be able to get from $120 all the way down to 0, counting by one movie at a time. Okay, so these X's are your movies. This is the amount on the gift card. So we graphed it and we labeled it. And you notice if you carried it all the way out to 12, that's whenever you get back down to 0. So I'm going to ask, what is the initial value of the gift card? Initial value is whatever point is on this vertical axis. Okay, what is the value when you're at 0 movies? That's 120. What is the constant difference or common difference? That's how much we're counting down by each time. Well, that's the minus 10 part of that. Minus $10 per movie. Okay. The domain and range. Domain goes from 0 to 12 movies. Range goes from 0 up to $120. Is this a linear function? Yes, because there's a constant difference of negative 10. Are its inputs an arithmetic sequence? Yes, because of the constant difference, or because it's linear. That would also work. If it's linear, it's arithmetic. Okay. Recursive and explicit functions. All right, notice this. In the recursive, if you have a +1, that is going to correspond to this 1 in the explicit. Okay, this is 1 because this is 1, and same vice versa. That is the pattern we're increasing by each time. Okay. On part B, explicit has a +2. That's where this 2n comes from. And remember that in the explicit, to find this part, we always go back a step to when n is 0. Okay, number 5, A and B, you're just asking if they're linear or exponential and giving some kind of explanation. If you are adding a common difference, or if you're adding to repeat the pattern, it's always going to be linear. If you multiply or divide, it will be exponential. So if the pattern is adding, it's linear. If the pattern is multiplying or dividing, it is exponential. Okay, now this column here on the edge gave you guys some trouble. It's just the ordered pairs. 0 for D, 10 for m of d, so we put that as an ordered pair. And then we can graph this. Now, you may not have done the graph because there wasn't a graph given. There will be a graph given to you on the test, so make sure that you are aware of how to graph this. Okay, notice that we've got to get all the way up to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's a 10, counting by ones. So on and so forth. Okay? And then it asks you to identify domain and range and explain the relationship they have on the situation. That just means, what do they mean in real life? What do these numbers mean? The domain goes from 0 out to 10. Remember, that is our D values. That's the number of downloads. Okay, 0 to 10 songs. That's all you need to understand, is that this is the number of downloads or songs. And then the range is the amount of money on the card. Okay, she has $10 to spend on the card. From 0 to 10 is what she can spend. Okay, 7, A and B, you are to identify it to be able to write the function rule. Okay, this is linear, so it's a function rule that will always follow this pattern, y equals mx plus b, or f of n equals mn plus b, where this m times the n is what we're changing by. So this is the function rule you should get. But part B down here is exponential. Okay? So we start by multiplying by -3. And you do need to have the negative here. On the test, I don't believe that I throw in a negative, but that's the pattern. We go from negative to positive to negative to positive, so you have to be multiplying by a negative number each time. Okay? So this is always going to follow the pattern of something to the power of n. And if we went back to find our initial value when x is 0, okay, we get 1. And so it's either 1 times -3 to the n or just -3 to the n. Okay? Number 8, all we're doing is plugging numbers in here. Remember, these bars mean absolute value. The absolute value of -30 here is just +30. Okay, again, if you need more time, just pause the video to look at these. Otherwise, I'm going to keep moving on. Okay. Cotton plant growing at a rate of 3 centimeters per day. Notice that if we just counted up by 1 centimeter each time, we wouldn't get to the full height of the cotton plant. So remember, we talked about making our scale fit the full amount of information. I want to show the height at its fullest for the cotton plant. At 80 days, it stops growing at 240. So at 90, you need to have leveled off here. Okay, so make sure that your graph looks like mine. And so when it says interpret the intercepts, that's the 0, 0. It crosses the x-axis and y-axis at 0, or 0, 0. So at 0, 0, the plant is 0 centimeters tall on day 0. That's the interpretation part of that. Okay, where is the graph increasing? It is increasing from 0 to 80. Okay. Maximums and mins, there's a minimum at 0 and a maximum at 80 days. Determine the end behavior. As x approaches infinity, or as x goes towards infinity, it's increasing. As x goes towards negative infinity, if I work backwards, it would be decreasing. That's all you need to have there. Does this function model every cotton plant? No. There's other factors we could have. Soil composition, amount of water, there's all kinds of things. You don't need to get into anything scientific. You just need to know that there's other things that would cause different plants to grow differently. Number 10, A is arithmetic, and B is geometric. Okay, number 11, I know I worked through this with some of you. This curve represents Jill's amount of text messages each day, and this line I've drawn in myself is this formula. Jack is always just going to get 3 messages each day. He's not going to increase and get more than that. He's not going to get less than that. He just gets 3 messages every day. But Jill, on day 0, she had 1 message to start with, where Jack had none. But on day 3, on day 1, she had 3 messages. On day 2, she had all the way up here at 8 messages. So Jill's amount of text messages increased more than Jack's did from one day to another. Explain the difference in the rates of change. Jack's rate is constant. Anytime it's a linear graph, that is a constant rate of change. Jill's rate is increasing. That's the important word there. The curve represents an increasing rate of change. Okay? Whose number of daily messages will increase more rapidly? That would have to be Jill, because hers is an exponential graph. All right, on number 12, this is the function we should get. Now, here's what I want you to realize. 2 over 16 can be reduced to 1 over 8. But to figure out your pattern, it is exponential. Okay, you can tell. And if you cover up all the fractional ones, you see we go from 2 to 8 to 32. You're multiplying by 4 every time. So we know we're going to have a 4 to the nth power part of our formula. But then to figure out what did I start with, if this is my first term, I have to go back to my 0 term, and instead of multiplying by 4, I'm going to divide by 4. If I take 2 over 16 and divide it by 4, I get 2 over 64. But again, that is reduced to 1 over 32. It's almost easier to reduce these first to see that pattern. And then it does say to find the 20th term. That's going to give you an exponential answer in your calculator. So if you did it and got this answer in your calculator, just copy it down. That's fine. Okay? You don't have to understand what it means. It just means it's giving you a scientific notation. This number is so big, it would be 34,359,738,370. Okay? So that is a billions number, and the calculator won't fit the entire number on the screen, even though it's coming really close. All right. Now, you do need to have something written down in the self-reflection. Remember, you get points on the test for answering these questions. So make sure you're writing something down in the review. Okay. And then our final page here, the performance task or performance event. This is a compound interest formula. Okay, and I will give you this on the test. You don't have to have it memorized. I will give you this to use on the test. But you do need to know what these things mean. A is always the amount of money in the account. I is the investment. This is a number 1. Plus, whatever the rate is, you need to change that to a decimal. And then this is the amount of time. In this case, in years. Okay? So that's the parts of the formula. So our formula should look like this. And it does say to simplify your equation completely. So I want to see that you've changed 1 plus the rate of 3.5%, or 0.035, into 1.035 by adding those together. That's what I want to see. So there's your formula. And then we're just going to find and fill out our table using that formula by plugging in 0 for t, and then 1 for t, and 2, and so on and so forth down to 5. And our graph doesn't really look like much of a curve, but it would be. So your graph needs to look something like this. I'll give you a little more instruction on the test. Part C asks you to find the value of the bond on her 21st birthday. We are not plugging in 21 for t because the bond starts on her 16th birthday. So at year 0, she's 16, 17 at year 1, so on and so forth. And then we find out that actually on our table, when t is 5, that is the 21st year. That's the 21st birthday. So we actually have the answer right there. Now you can plug it in and get this answer in your calculator, or you could just copy it down from the table. It says round to the nearest dollar, though, so it's $3,563. All right, your bank offers you the opportunity to reinvest your $3,000 into a savings account that earns you $100 per year. That is a linear equation. You're going to start with $3,000 and just add $100 every year. Okay, so use your calculator to determine at what point in time would the two accounts be equivalent. Which account is better investment if you plan on keeping the account open indefinitely. Okay, so they're going to be only equivalent at year 0. The exponential model will always have more money in it than this will. Okay, because at year 1, there's $105 added in, whereas there's only $100 on year 1 here. So they only will be equivalent before you make the investment. So the first account is better because it always has more money in it. All right. If you're grading this, each problem is worth 2. We can look at the actual percentage when you get to class. You don't need to put a grade on here. I just want to make sure you knew how to do these problems. So bring this into class, and good luck on your test.